Okay, I will formally begin our lecture today. Last week, we introduced something about the objective-oriented programming, and we introduced the classes can be a type, right? So to specify more clearly, I find an example from online that this is a mode, and the mode create 4 cute toys, right? And we can regard the class, which we say a certain kind of types, they are more like a template. That is the mode. And in the red circle. And for all the classes, okay, you don't need to specify the details for the classes. What you all need to know is like the instance variables, like the name. And we say that it is attributes. And also some method like get names, set names. And then this is the template for us to use to create the cute toys. And then for these 4, we say they are instances or objects for the certain kind of classes because it is a concrete toy, not a mold, not a template, right? It is a concrete thing. So for the first concrete thing, I can give it a name as Alice, and it has some method like get name and a set name. And for the second instance, it has a name of Bob. And for the third one, it has the name John. And for the fourth instance, it has the name Laura. However, this is only happened in the instance. It is not happened in the classes. So let's get back to our codes last week here. Okay, let me make it more big. As we can see, this is a class. In the left side, it is a class. We say it's a template. So we only know it has the name attribute. It has some method like set name and get name. We don't know what the name it is. But in the right-hand side here, we create an instance. That means we want to make it more concrete. And we use the scanner to give it a name like Jane Green, something like that. And then we call the instance set name method, and we set the name as Jane Green. We fetched from the terminal, and once we have done the set name, we can output the account get name, which is the Jane Green. That is what we are talking about last week. So let's get back to the picture. Here, it is almost the same thing. It is not a count. It just in the picture, it is just toy, but they are almost have the same meaning, like their count. We can also say it is a toy. It has name, which is its attribute, and some method like get name, set name. And then once we have this template, we can create the concrete instance. We say the objects like that. I will upload these pictures to the Brightspace after this lecture. And that is for our previous lectures. Okay, let me save it. And then let me get back to the slides. Here is our slides for our last lectures. Okay, since almost everybody is here, and then I will talk something about our office hour today. In today's office hours, I not scrutinize, I just watch some students write their own codes. I find you students are pretty smart, right? Like you know some meaning of the codes. However, the problem is that you are afraid of making mistakes when writing codes. For example, like you may worry about, okay, how what if I missed the system in this line of code? Okay, if you miss it, you just input that. I mean, sometimes you may not know how to code, but you can read the solutions and then copy it, and you memorize everything. At current stage, you still need to memorize the code. Also, it hurts a little bit ridiculous, but it's the best way to get started. Like, you memorize. Okay, the first thing I have to do is always I create a class, begin with the class name, and then after in the class I create a main method. I input PSVM, right? I always say PSVM because this is the shortcut to create the main method. And then once I have done, you just type everything in the solution you can get from the assignment solution. You type everything there, like S, C, scanner, and input equal new scanner system in. You just follow the solutions and write your own code and make the program run. Because when today's office hours, the students sometimes make mistakes, like she may misspell some keywords or misplace some symbols. But it's pretty usual. It is not even a mistake, right? At the current stage, because you are learning. So I expect you that you can practice the solutions for the assignment. I have already uploaded all the solutions to the for the chapter 2 in the assignment. So you can practice the programs by yourself. If you are not feeling comfortable, or if you are not confident of trying, you can just let me know, or let's make an office hour and I can accompany you to write your own code. It's fine, but try to practice, write your own code, follow the code in the slides or the code in the solution in the assignment. Type everything you have. Type everything in the solution, and then you can make it. And that is for today's office hours. For today's office hours, we go through several questions, problems in our chapter 2, and also our exams. Nothing special, just review some old things. So you don't worry about that. I didn't bring anything new to the office hours. Okay, then let's review something about the classes. Okay, let me get my whiteboard. So in our, I think it's better for me to share my whole screen. Let's read the notes and the programs together. Okay, I will put the code here in the left side. Let me here like this. Okay, let's read the code and the slides together. Here is for the account test class here, which is reference to the bottom code here. So it creates uses an object of class account, which happens there. Create an instance objects of a class, which is a type. So the scanner method next line reads characters until a new line character is encountered, and then returns the characters as string. it refers to this line. That we knew a scanner here in the line 6. And then we use the next line method, reads the characters until a new line character. We say it is the enter, keyboard enter. We stroke the keyboard enter. That means we change a new line, right? And that is the new line character. And then we return the characters as a string. Here, that means, let me try. It reads a name like Jane. Here, right, in the terminal. And the scanner use the next line. It will read the whole line until I stroke the enter. And then the Jane is read by the input scanner and then assigned to the string variable, which is the name. And currently, the name refer to the Jane here. And that is for this slide. And then next, for the create a new instance, that means a class instance creation expression, which refers to the line 9. It begins with the keyword new is here. We knew something, like here it is new a scanner. We knew an account. This is the class name, referring to this one. And a constructor, we will going to talk it later, but here we just get touched a little bit. A constructor is similar to a method, but is called implicitly by the new operator to initialize an object's instance variable at the time the object is created. I will show you the instructor later. And then let's go next slide. Here, to call a method of an object, follow the object name with a dot separator. We said if you want to invoke a method, you always using the dot and with the method name, like here. Here we create an instance, right? My account. And then we using the dot get name. We invoke this method referring to the templates method here, get name. It will return the name. And the method name and a set of parentheses containing the method's argument. Currently, we don't have argument there, but in the future, we may. And that is how we use the get name method here. The instance name dot method name. And usually for the string variables, local variables are not automatically initialized. It is here. This is a string type name. It's supposed to be null, although we don't explicit, but usually it has a default value, a value provided by Java when you do not specify the instance variable's initial value. And the default value for an instance variable of type string is null. That means if we don't specify, the name is null. You can also write like that. Like that. But you can also ignore it. They are the same. And for the set method, it refers to the searching line that a method called supplies values. The value supplied is the name. That is referred to the input next line we fetched from the terminal. That is the Jane here. And here, the name we say also appeared in the account class, that is the string name 1 here. We say it is an argument. Or we say a method parameters. Each argument's value is assigned to the corresponding parameter in the method header. And this is the method header. We can expand it. Not only the one line style. Okay. Usually, the number of arguments in a method call must match the number of parameters in the method declarations parameter list. That means here we invoke, it's the same thing. Invoke means call. We call the set name method, right? Here it is only one parameter, which is corresponding to here. It is also one parameter. If there is another parameter there in the account class, when we call this method, we should also include the other one. So that means the number of parameters should be the same. And for their types, here it says that the argument types in the method call must be consistent with the types of the corresponding parameters in the method declaration. Here is a string. So the name here in the account test Java, it also has to be a string. How can we specify whether the name is string or not? In this line, we already declare it as a string type. So that's it for the set name method. And this is for the compiling the projects using command line that you can using the command line using the Java C using a star with .java to compile both of these two files together. I will not show that because most of times you will not use it. Most of times you will only using the IntelliJ to compile it. So I will skip it. Okay, then let's talking something about the UML class diagrams. The UML, that means it's a certain kind of designing tools that provide you to visualize your classes. In the UML, each class is modeled in a class diagram as a rectangle with 3 compartments. The top one contains the class name centralized horizontally in boldface. Okay, it is a UML class diagram for class account. It is a little bit, right, similar to this one, right? Account, name, get name, set name. Actually, is a simplified UML diagrams in this picture. And in the top, you always write the class name, which is the account. In the middle compartment here, you specify the attributes. That is the name. And the type of the attribute is supposed to be the string. And in the bottom compartments, you have to write something about the method you design, like set name and get name. And there are some more specific things for the UML class diagrams. In the middle compartment, we say here the name attribute. It contains the class attributes which corresponds to the instance variables in Java. And for the bottom compartments, it contains the class operations. We say the method, which correspond to the method and the constructors in Java. The UML represent instance variables as an attribute name, followed by a colon and the type. Okay, this is not very standard. I can use this one. Let me get a shortcut. Okay, here. This one, so we can make them pretty clear, more clear, not pretty clear. So the bottom compartment contains the class operations, right here, which corresponds to the method and the constructors. And the UML represents the instance variables as attribute name here. It's not very clear. Okay, like that. And for the private attributes, they are preceded with a minus sign, which refers to this one, a dash name, that is a minus sign. And the UML method operations by listing the operation name followed by a set of parentheses. That is here, parentheses there. A plus sign in front of the operation name indicates that the operation is a public one in the UML. Here, both the methods are plus. That means they are public method. And for the return types, the UML indicates an operation's return type by placing a column and the return type after the parentheses. As you can see the get name here, right? After the get name, we use a column and a string type, which is a return type after the parentheses, followed by the operation name, get name. And the UML class diagrams, they do not specify return types for operations that do not return values, like the set name here. After the parentheses, we don't have anything. However, if you want to return something, you have to specify using a column with the type. That's the difference. So in this way, declaring an instance variable as private, we say we're using a minus sign here, right? It's known as data hiding or information hiding because other classes cannot know the name for the instance directly. They can get the name only by using the method get name string. Otherwise, they cannot. They will fail. And for the parameters, the UML models a parameter of an operation by listing the parameter name followed by a column and the parameter type between the parentheses after the operation's name. That is referring to the content between the parentheses. Name.string, that is the parameter, how it presents in the UML class diagram. And that is end for this stuff. So then for the static method main, we will only touch a little bit about it. That in a specific classes, you must call most method other than main explicitly to tell them to perform their tasks. The key part of enabling the JVM to locate and call method main to begin the application's execution is a static keyword, which indicates that the main is a static method. We say here, PSVM, right? We always using this shortcut to create the main method. Here, the static void main. That indicates the main is a static method that can call without first creating an object of the class in which the method is declared. Here, since main, we have a static there, so we can directly run it, right? However, can we run the account directly? Obviously not, because as we can see in the left side, we don't have the green button. But why? I don't know why. It is the scheme by Java. We can only by creating an instance for the account, right? Create my account equal to new account. And in such a way, we use the account.java file. So that's the difference. Here, we do not have public static main method. We don't have a static keywords in the account.java. So we need to using the account, my account equal to new account code to create an instance. In this way, we use this account class. However, when we are invoking the main method, we don't need to create the main, right? We can directly run this file. That's the difference. And some notes for the import declarations. Most classes you will use in Java program must import explicitly. Like here, it is the scanner class. And there is a special relationship between classes that are compiled in the same directory. Okay, in the future, we will get in touch with the special relationships. But currently, we just know there's some special relationship. By default, such classes are considered to be in the same package, known as the default package. Classes in the same package are implicitly imported into the source code file of the other classes in that package. So we say this is the source file. This is a folder here, right? We say it's a package. So here, the account and the account test, they are in the same folder. So we say they are in the same package. In this case, the account test file want to use the account type. We do not import the account, right? Like we do not write such a thing, account. No, we don't need to do that because they are in the same default package. As you can see, there is an error message indicating such a thing. But if the account is in another package, for example, let me create a folder, a package folder that is, we say source, we say a help, right? And then we move the account to the help package. Okay, reflect. What you will notice is that here, the account, there is a package indicator to indicate that the account is in the package help rather than the source. However, in the outside package, in the outside help folder, this one, it doesn't have the in package help. However, here it converts to import help.account that explicit import the account file from the account in the help package. Okay, something when talking, it will be complicate. It will become complex. But when you are trying to write your own code, it will be simple. So I encourage you to create such a structure of folder to practice. Like create the account in the help folder, and then you call the account class from the outside package there. So you will know the differences. Okay, then let's go to the other thing. An import declaration is not required when one class in a package uses another one in the same package. When these two files are in the same folder, I mean in the same source file folder here, we don't have this line of code. So an import declaration is not required if you always refer to a class with its fully qualified name, which includes its package name and the class name. We do not. But if you are separating them, well, you have. Okay, that is the data hiding. That means you have a name, but for some reasons, okay, I cannot write. Okay. Can I still cannot write. Why? Please wait a moment. Okay, there's something wrong with my whiteboard today, so I will not use it. So that means if you want to fetch the name from outside, if you want to fetch the name, you cannot directly do that. What you can do is, first you invoke the getName method, and the getName method gets the name. That is data hiding. In two ways. That is also the things we used in this line. Suppose I do not using my account, right? I do not using that. Can I directly get the name? Let's see the name, right? The name. Can I? No, I cannot. Let me see the output. It says cannot resolve the symbol name. What we can do is only by, or we say we using the my count dot. Here, what he said, the name has private access in help.account. That means it is private. We cannot directly fetch the name. What we can do is only to using the getName method. GetName method to get the name for the account instance. That's the data hiding. And then we are going to create our instance using the second way, that is initializing an object with constructor. Here he said that each classes you declare can optionally provide a constructor with parameters that can be utilized to initialize an object of a class when the object is created. Okay, you should know that it is optionally. That means you can do that or you don't need to do that. Both are fine. And Java requires a constructor call for every object that's created. Actually, even though we don't write it explicitly, the Java will create a default one for us. Although we don't write the thing, we don't write the code, but it is something there we cannot see. It doesn't have. So how can we create the instructor? In this block, in this yellow block, it is the one way of create a constructor. Why it is one way? Because we can create several instructors there, but this is only the one way. Here for the constructor, let me type. For the constructor, it usually has the same name with the class name. Here we have the class name is account, right? So the constructor's name is the same. We use public account, followed by the string name, the parameters. With the same method as the set name. You say this dot name that equal to the name. And the name, we can say it is the name2. And this is the name too. This one, we get this name, and we pass in this method, we pass the name to this name. This refers to the instance object itself. Like here, the this refers to the my account here. So let's see. The constructors cannot return values. Since it doesn't return values, so there is a difference, right? Here in the getName method, we return something. And in the after the public, we have a data type that is string. That is for the method, we need to return something to the caller. However, constructors, usually we don't need to return anything. So we do not include the string type. We do not include the type, no matter it is string or integer. And we don't use the void. We just public account is enough. And the default constructor, if a class doesn't define a constructor, like previously, we don't have these 3 lines, right? The compiler provides a default constructor with no parameters. And that means for the default one, it is public account. That's why I say there are several ways to initialize the constructor. So this dot name will be null. That is the default constructor. So we have 2 constructors here. And then since we have 2 constructors here, this is correct, this is correct. So here it doesn't throw error. If we declare a constructor for class and the compiler will not create a default constructor for that class. That means if we define the construct by ourselves and the compiler will not create it by itself, we can take it and we can remove it. It doesn't affect the behavior. And then let's see, how can we using the account constructor to initialize the name and the instance? Since we declare a constructor like that, right? We can pass the account name automatically. I make them into one line so you can see more clearly. So I will remove this default one because it will affect us to explaining the default constructor. Here, as you see, since in the account class, we do not specify the default constructor, rather we use our own constructor like that. That means when we are creating an account instance, we should pass one argument to here when we are creating the instance. That is a green. That means if we are declaring an constructor in our template, we say the account. When we are calling it to create a certain kind of instance, we need to pass the parameters accordingly. Here, it requires the name, and there we should write the name. So here we no longer need to use the scanner to create the name. So here, we fetch this name, and then since we have this method and we no longer need the set name method, so this line we have to delete it accordingly. And let's see how it works with this code. Let's try. It is the same thing, like the name is Jane Green. As here, we set the name using the constructor rather than the set name. Although they are different methods, one is the set name, the other one is constructor. But both of these two have the same behavior. That is, set the name of this instance, my account. Give it a name as Jane Green. And we call the my account get name method, and then we can get the construct method for the account. That is the Jane Green here. Okay, let's see how it works with the UML diagrams. Here, adding the constructor to the class accounts UML class diagrams, the UML models constructors in the third compartment of a class diagram. To distinguish a constructor from a class operators, the UML places the word constructor between guillemets before the construct's name. That is like that here. This is the constructor indicating we are going to create a specific instance with the constructor account setting. Okay, then we are going to change the behaviors for the account. What if my account should have a balance? And the balance is supposing to be a floating point numbers. So what is a floating point number? We say we have integer, we have float number, we have double type. So we always say that an integer is a whole number. That is 1, 2, 3, 4 without dot, 20 dot, 40 dot 0, 3. We don't have the tail. We only have a whole number, the first part of the without precision. And the floating number, we say the float or the double type. They are a number with a decimal point. Java provides two parameter types for storing floating point numbers. That is the float and double. The float presents a single precision and the double presents double precision. That means the length for the double is twice as the floating numbers, the float type. Here it says. Okay, the floating point literals are type of double by default. That means if you are declaring some floating numbers in the program, they are usually is double, not float. Okay, that is not too important. Okay, coming back to our program, how can we add such attributes? So here, since we are going to have a balance, we are going to declare another attribute, right? Private double balance. This is a new attribute we are going to have. And then in the constructor, we can change because when we are creating a bank account, the balance always to set to be 0, or you can deposit some money to your account when you are creating an account. Sorry. So let's change the constructor behavior. Here, we set two parameters. One is the account name, another one is the balance for the account. This dot balance equal to balance. Okay, to making you don't feeling uncomfortable, so I will change here the balance to be balance 1. Okay, balance 2 may be better. Balance 2, balance 2. We can do such a way. However, as we know that a balance, it cannot go negative, right? So we'll have to using a if statement to make the decision. Like if balance over 0.0, over is a positive, we say. If a balance is a positive, we set the balance. If the balance is negative, we don't set. We just leave the balance to be default value. So here we add the if statement. Sorry. And that is the way. Okay, then we still need to one more behavior, that is to deposit our money, right? So here we initialize one more method, that is public. Currently, you can declare every method as public. Void. That means we do not need a return type. We just do the behavior. We don't take back any information. So that is the void. Deposit double deposit amount. So in this method, we should figure out, like if come a client to me, he wants to deposit 500, it's fine. What if he wants to deposit negative values, like he wants to deposit -10, that means he's going to take money from me, withdraw money. Okay, since it is a deposit behavior, it is not withdraw. So we are not allowed such behavior. In this case, we need to use an if statement to figure out whether this action is valid or not. So we will have if deposit amount is equal to 0. If the client is going to deposit $10, which is positive, and then we have a balance here, right? That means the balance for my account. So he is going to deposit some money. That means the balance to be increased. So here we are going to update our balance. That is why it is wrong. Okay, balance misspelled, typo. So we should assign the new balance to it, which is the balance, old balance plus the deposit amount. And that is update the balance. It is a little bit similar to set name, right? We set name, it doesn't have the return type because we only do the action. We do not require anything from the program, right? We just set the name and then the program set the name. And here we deposit money and the program update the balance. And then we'll have to define another method, that is the get balance. Like we are going to check how much money we have in our account. So here we use the public access modifier. Double means we are going to get some numbers from the cashier, right? She or he is going to telling me what is the number we have in our account. And since the balance is not a whole number, like I have 1,020 cents in my account, so this is a floating number with precision decimal point. So I need to declare this method should return me a double type. So say that is get balance. Sorry. So we just need to return the balance we have. It's fine. I was typo, sorry. Okay, done. And that is for the set get balance method. And this is a little bit similar to the get name, right? Both things, they have return type because the program has to provide some information to me. Like here, it's supposed to provide the name to me, and the name is a string. Here, the program is supposed to return the account balance to me. So the balance is supposed to be a double type here. And both these two, since they are returning something to me, they have a return statement like that. And that is for this method. The others keep the same. And then in our test method, let's see how can we get the method, how can we update and set the balance and update the balance, get the balance. Here, let's go to the constructor. Since the constructor here, we have to we use the constructor to create the name and the balance. So here we still need to match the number of parameters. Here we say, suppose we have 50. Like when we are creating the account name is Jane Green, and Jane Green deposits immediately $50 into her account. Okay, that is for the Jane Green's account. So let's output. We can try the get. We get name, right? But we also have a get balance method there. So let's see how much money currently she have. Okay, it's no. Let me see why. I get name. I get balance. That's a little bit weird. Made something wrong. Oh, I see. Because this is a string? No, I don't think so. But let me try. Let me change it into F. That means I'm going to accept integer. Oh. Oh, let's try. Oh, it's still 0. Let me debug it. Okay, account Jane Green is supposed to be 0. That means here I failed. Why I failed here? The balance 2 is 50. Oh, I see. They should keep the same. Oh, here. I made it wrong there. There it's balance equal. Here, I'm trying to distinguish the amount I deposit is bigger or smaller than 0. And after that, I change the name into balance 2 right here. I should change it to the balance 2 accordingly. That should be correct now. Let's go. Let's have a look. And then, okay, fine. It's now output correctly. So as you can see, currently I have a new, I create a new account and I set the initial value of the balance is 50 and I get the name, I get the balance, everything is output. Okay, I want to only using one line. Okay, and after that, let's see how can we deposit some money. Okay, in the slide, he used the scanner to obtain the input from the command window to accept the user input as the deposit money. Okay, we can do the same thing. Like declare scanner input, which is new scanner system.in. And let's get a prompt. Please enter the deposit amount. Okay, we do not change a line, so we only using the print with a space. And then we declare a variable to accept the deposit money. That is input dot next int, right? Okay, next double, as we are using the declaring the double type. Okay, double. As once we have done, and then once we have done, we upgrade my account. Sorry, my account. We call the deposit method here, right? Dot deposit, and the amount is coming from here. And once we're done, let's see the balance. Okay, let's run. Okay, here the name is Jane Green. Oh, sorry, the amount is the initial balance is, okay, let me restart. The name is Jane Green. The initial balance is $50, right? And let's suppose I want to deposit 13. Okay, here, sorry. The balance, that is coding. Sometimes you make mistakes and you just need to revise it. It's fine. Don't worry about making mistakes. Everybody make mistakes and making bugs. Fine. And here I enter the deposit amount that is 13. and it's supposed to be the addition with the $50. That is 63. That is the upgrade account classes. So almost the same thing. And let's see how it's explained the program. Here, the scanner method next double, referring to the line 16 here, returns a double value that is from the user input here in the command, in the terminal. And here, the original is code in the slides using a formatting point number for display. I didn't use that. Let me change it. Like here, I using this dot F, right? I don't change the first line. I change this line. I use dot 2. Okay, let's see what's the difference. Okay, as you can see, if I don't write the dot 2F in the first get balance here, it will output 3 digits here, right? Once I write dot 2, and then I only get 2 digits. That is a format specifier that it specifies that 2 digits of precision should be output to the right of the decimal point. If I change it to 4, let's see. And that is, the tail is 4. And that is for the, sorry, for the account formatting. Okay, we will skip the error. Okay. The default value for an instance variable for type double is 0.0, and the default value for an instance variable of type is int. That is pretty trivial. And here is the UML class diagram for account class. That here it adds a deposit and a get balance method for the UML diagram here. For the deposit, it passes the parameters, that is the deposit amount, which is a double type. And after the parentheses, we don't have anything because it's a void method. For the second one, get balance, in the parentheses, nothing there. That means we don't need to provide it anything. And for the double here, it means that this method is going to provide something to the user, to me. Like it should provide a double integer, the double type floating point numbers to me. And that is the UML class for the account. And I should mention something about the primitive type and the reference type. You'd better to memorize that for the primitive types, there are only Boolean, type, char, short, int, long, float, and the double. All the others are reference types. And also the classes. The classes, we say that the account, right? A class can be a type. This type is also belonging to the references type. Okay, sorry. A primitive type variable can store exactly one value of its declared type at a time. A primitive type instance variables are initialized by default. That means for those primitives, for the Boolean by chart, we say, okay, let's take int for example. For the int variable, we can only store one value for it. Like we say, let me see whether we have examples. Okay, we don't have examples there. Like we initialize an integer I and we assign a value 2 to it, right? And we can only assign one value to it. But for the reference type here, we say we can assign name, we can assign the balance, right? We use the instructor to assign the initial value to it. That's the difference. And there are some other differences. That is like the variable type of the type Boolean are initialized to false. And the reference types variables stores the location of an object in the computer's memory. Okay, I would like to say that currently what you need to do is only memorizing it because it's related to some of the computer systems and computer architectures. And such variables refer to objects in the program. The objects that referenced may contain many instance variables and the method. That is the examples here. We have name, we have balance, and the reference type instance variables are initialized by default to the value null. Usually, they are initialized by null, but you can also skip it. A reference to an object is required to invoke an object's method. Okay, that is meaning that here, we are going to invoke its constructor method. A reference to an object is required to invoke an object's method because we are reference to this thing, right? We first need to create it and then we invoke it using the constructor to set the initialized value. A primitive type variable doesn't refer to an object and therefore cannot be used to invoke a method. So for the int string or for the int byte char long, they can only present for a specific variable. They cannot reference to a class. That is what it says. And that is all for the chapter 3. Let me see. How about whether we should get started for the chapter 4? Let me find the Okay, chapter 4 is easy. We will go through it quickly. Sorry. Okay, it says that before writing a program, we should have a thorough understanding of the program problem and a carefully planned approach to solve it, right? Understand the types of building blocks that are available in employed proven program constructions techniques. In this chapter, in the chapter 4, we are going to discuss some control statements, like if else, and while statements, and some compound assignments, increment and decrement operators. We have already talked about it. And here we are going to introduce some little bit about the algorithms you may, in concept, only in concept. What is an algorithm? The algorithm is like a recipe, like the recipe to do a specific task. Like here it says an algorithm is a procedure for solving a problem in terms of the actions and the order. The rise and the shine algorithm followed by one executive for getting out of bed and going to work. Okay. This algorithm has 6 steps. The first one is get out of bed. The second one is take off pajamas. And the third one is take a shower. The fourth step is get dressed. The fifth is eat breakfast. And the last one is couple to work. Okay, however, you can still taking them in different order. Like you get out of bed, take off pajamas, and then you don't take showers. I mean, you skip the step 3 in the previous bullet point, right? And then you just directly get dressed. And then you take a shower. Okay, it is normal, but sometimes when you are making mistakes, that is a bug. Because you cannot get dressed and take a shower because your weather or your clothes will be get wet. And then eat breakfast, couple to work. It's fine. So specifying the order in which statement executed in program is called programming control. Program control. A pseudocode is an informal language that helps you develop algorithms without having to worry about the strict details of Java language syntax. Particularly useful for developing algorithms that will be converted to structured portions of Java programs. Similar to everyday English, I would say that this one, the recipe, get out of bed, take off pajama, take a shower, get dressed. This is already a pseudocode because it has actions, it has order. So this is a pseudocode of the algorithm. And the control structure is a certain kind of special sequence execution. That means the statements in a program execute one after the other one in the order in which they are written. Of course, there are some transfer of control that like various Java statements enable you to specify that the next statement to execute is not necessarily the next one in sequence. You can jump. Demonstrated that the programs could be written without any go-to statement. And this is the control structure. And the sequence structure in Java, they are built into Java. Unless directed otherwise, the computer executes Java statement one after the other in order in which they are written. The activity diagram in figure 4.1 illustrates a typical sequence structure. Let's see what's that. Here, we start from the bullet, and then we add grade to total. It corresponds to a Java statement like that. Total equals total plus grade. And then I add I to counter, corresponding to the counter is equal to counter plus 1. And then we use a bullet with a circle to indicate the end. The Java lets you have as many actions as you want in the sequence structure. Anywhere a single action may be placed, we may place several actions in sequence. For the control structures, for the UML, we can use UML activity diagrams to indicate such a thing. Actually, this is another type of UML diagrams, which is a little bit different from the account classes we just mentioned in previous session. But this is another This is another type. We call it an activity diagram rather than a class diagram. For the control structures, it models the workflow. We also call it the activity of a portion of a software systems. It composed of symbols like action state symbols, diamonds, small circles, and symbols connected by transition arrows. Here, like this, those are transition arrows, means transition to a different state. And also represent for the flow of the activity. And it helps you develop and represent the algorithm and clearly show how control structure operate. Okay, we have just mentioned that. So then there we are going to talking something about a selection statement in Java. We have already used the selection statement. That is an if statement. If something is true, or if some, like we say to distinguish whether a number is odd or even, we say if the number mode, we use the percentage symbol stands for the mode, the mode operation. We say, let me write here, like if number mode 2, right, is equal to 0, right? It's an even. This is an even statement. It performs an action. If a condition is true, we skip it. Otherwise, it's false. This is a single selection statement. It selects or ignores a single action. And of course, we have some other type, that is if-else statement. It performs an action if a condition is true and perform a different action if the condition is false. This is double selection statement. And of course, we have switch statement. It performs of several actions based on the value of an expression. That is multiple selection statement that selects among many different actions. Okay, let me see whether we have, okay, it's too far from there. Okay, I'll give you an overview of that, and then we will discuss one by one. An iteration statement in Java, that means for iteration statements, that is, there are 4 kinds. The first one is while statement, and the other one is, the second one is for statement. Both of them perform the actions in their body 0 or more times. And if the loop continue or condition is initially false, the body will not execute. And the third one is the do while statement. It performs the actions in its body 1 or more times. Chapter 7 presents the enhanced for statements. Currently, we only get touch of it. And every program is formed by combining the sequence of statements, selection statements. There are 4 types, and iteration statements, 3 types. As appropriate for the algorithm the program implements. The control statements can be seen as an activity diagram. Usually it has the initial state and the final state. They represent the control statement's entry point and exit point respectively. And usually they are single entry and a single exit control statement. And the control statement stacking means they connect the exit point of one to the entry point of the next. For the control statement nesting, that means in one control statement, you can nest another one control statement inside. Don't worry about that. We will go through examples for them one by one in maybe next week, because next lecture is a lab. currently we are just go through some notions, concepts of it. For the if single selection statement, here it is the pseudocode, like if student's grade is greater than or equal to 6, and then we print pass. If this condition is false, that means the student's grade is smaller than 60, and the print statement is ignored. That means we will skip the pass. We will skip the print pass. That means we will print nothing. And then the next pseudo statement in order is performed. Indentation is optional in Java, but indentation in Python is required because it emphasizes the inherent structure of the structured programs like that. We always, in the block, we use tab indentation. Usually it stands for 4 symbols of the space after the first line of code. Here, the preceding pseudo if in Java. If student grade greater or equal to 16 and the print pass, we use the system.out print line pass. This is a real code corresponding to the pseudocode. And in the UML, how can we visualize it? Here, it is the if statement. We start from the bullet point, and we're using a diamond to indicate a state. Here, we make the decision. If the grade is equal or bigger than 16, we go to the right, and then we print past, and then we end the program. Otherwise, we do nothing. Here, we strictly go to the end. That each transition arrow emerging from a decision symbol has a guard condition in squared brackets next to the arrow. If the guard condition is true, the workflow enters the action state to which the transition arrow points. For the if-else double selection statement here, for the if-else double selection, it specifies an action to perform when the condition is true and a different action when the condition is false. The pseudocode is like that. If else, if it corresponding to the if else in the real code here. If it is greater than 16, you print pass. Else, otherwise, you print failed. This is the if else statement. And how can we visualize it in UML activity diagram? Here it is. We use two blue block to indicate. The first one, if it is greater than 16, we go to the right direction. If smaller, we go to the left direction. And this, a circle with a bullet means the end of the program. And now, of course, we can use several if-else statements nested together. Here, a program can test multiple cases by placing if-else statement inside other if-else statement to create a nested if-else statement. The pseudocode, that is. If the outermost block is if-else here. If it is greater than 19, we print A. Otherwise, we made another decision. In the other decision, we say if the grade is greater to 80, we print B. Otherwise, we go to another decision again. The decision here is going to specify whether it is going to print C or D or F, etc. That is the nested if-else statement. And this is the whole real code for the if-else statement, how it works. Like if something bigger than 90, and then you print out something else. And then in the else block, you make the decision again. Like if the grade is greater than 80, and then you print something. Otherwise, okay. And since it's a nested else if, you are going to make comparison. The student grade is greater than or equal to something like that. This is the if-else selection statement. Okay, we have to be careful about the dangling else problem. Like we always enclose the control statement bodies in braces. This avoids a logic error and cause the dangling else problem. We investigated in dash. Okay, it doesn't have the problem. It doesn't have give us an example. That means we may here for the dangling. That means they are not paired together. Like we have if else there. And then what if I forgot the if there? Right. This is dangling. We have one if the number of if is not equal to the number of else. They are not paired together. So that is else dangling. And we are going here, it introduced the blocks concepts again. We say that everything between the braces, right? The curly braces, we call that they are a block. That the if statement normally expected only one statement in its body. Here, the block is its body. To include several statements in the body of an if, we enclose the statements in braces. Here, it embraces one statement. In this block, there is one statement. However, in this block, we have two statements there. A block can be placed anywhere in the method that a single statement can be placed. And there are mentioned some other errors. The first is syntax errors that are caught by the compiler. A logic errors we also mentioned in the second lecture that and it has an effect at the execution time. Also, we have some logic errors. It causes a program to fail, like you divide 1 over 0. 0 cannot be in the downside, right? 0 can only be in the upper side when we are doing division. And for here, just a block can be placed anywhere a single placement can be placed. It's also possible to have an empty space. That means you can always, if you don't want to write anything here, it is valid when you are leaving the block as empty. And when you are placing a semicolon there, it's also valid. Okay, I think today, since we don't have break, so today our course will be end here. If you have some questions, you can stay. Otherwise, you can leave now. And the next course, we will have a lab. Okay, good night, everyone. Good night.
Good night.
Good night.
Great one.
Thank you.